to show tan c minus t derived as the Euclidean geometry. Normally we do the trigonometry in algebraic way, but we don't do trigonometry in geometric way. Suppose this is this green line here is made with the given line segment as per geometrifying trigonometry theory. This line makes the angle C with this green line, and this line makes the angle D with this green line, and this one is the perpendicular. So naturally this red line is L into tan D. Now this line which is selected, which is from here to here, this line is L into tan C. Now if we construct the separate triangles like this and this big line L tan C, then it forms a triangle. If we take this line and L tan D, this line, then it is a separate triangle. Now when we try to forget this line and this line and this line, we have only the line with this to this, and this one is the L tan D, and this point to this point is the L tan D. This point to this point is the L tan C. This point to this point is the L tan D. So only this part, this here to here, is the L tan C minus tan D, which is taken common here, which is triple arrowed here. That is the L into tan C minus tan D. Now if we take the same angle here with the, as it is making angle here, it has a construction protocol by drawing the two circles. That is your homework. You can think how to copy this angle D here as it is. If we want to get this copy here, then you can check it that this angle, because this one to this one will give the same value, and that is the angle of tan D. Now if we take the parallel line here, and suppose dynamically we are changing the size of this thing with the changing angles, and you can see the two parallel lines are here, where we can get the point of intersection such that this portion is L into tan C into tan D. Normally people don't get this idea every time. That which line segment is going to show this value. Now if we draw a parallelogram here, with these points, then we can become sure that this whole line is 1 plus tan C into tan D into L up to this. Okay, this is transmitted here, so this line is, now if we delete this, then we can understand this is the L into 1 plus tan C into tan D, and this line is the tan C into tan D, and this part was the L. So L into tan C plus L into tan C into tan D is this red part, and L is originally here, so the total length is L in whole into 1 plus tan c into tan d. That is transmitted here since it is parallelogram, and it is the theorem in the Euclidean geometry that if we draw it in this way, then if we draw this line here, then this angle formed here and with these two lines is equal to the c minus d, and from this the angle c minus d is here, and you can cross verify this c minus d, and if you get the copy of this angle here, this angle is also of the same value as this one. If we change the values, then you can see that we can change the positions to check the values changing here. This kind of theorem proving is important for understanding the trigonometry with pure Euclidean geometry.